Hey, really good to see you again. So I've pretty much finished the overall design for this awesome phone in terms of the hardware and the layout and placements. Let's go through it and you can let me know what you think. So starting off down here at the bottom, we've got a USB-C modular port along with two user buttons which are programmable within software. Continuing on the front, we move up to the top. We've got an earpiece speaker, which is also modular. Attaches to the back, just with a simple board-to-board connector. And also at the front, we've got a NeoPixel notification LED. So that's red, green, and blue, with 65,000 colors. And the power switch, which is kind of the sleep-wake button rather than the overall power button. Going to the back, we've also got another NeoPixel LED, which works as the rear flashlight. And we've got the SIM card holder, which is on a modular board, with potential options to go in for eSIM if people wanted that, or any other future modifications. On the other side, we've got a modular USB to SD card adapter. Because the port here is USB, we can upgrade this SD to one of the brand new Extreme SSD, the new tiny form factors. I'll put a picture up here on the screen so you can see what I'm talking about. Yeah, so upgradable in the future to pretty much anything. Potentially also maybe, excuse me. Potentially also maybe put a an M.2 module on there for USB to M.2 storage. Further down, we've got the connections for the NeoPixel I2C lines coming from the main board, as well as an MPU 6050 accelerometer. We've got the connection for audio input, as well as USB 2. Although this is a USB 3 hub internally, to begin with, I'm just going with USB 2 for the prototype. Just a lot easier to route the cable connections. But eventually I will go up to USB 3 for all these things. And then this is the M.2 radio module, removable, upgradable. And then a flight mode switch, which enables or disables the power directly to the M.2 radio module. Coming down, we've got the back of the screen, which connects to USB-C and an HDMI adapter. I spent a few months working on these. These connect to the main board via the board-to-board connectors, which will just be for small flexible cables, just to bridge connections. The HDMI port sits slightly higher than the USB-C, as you can see in this picture. So yeah, this is the best solution I've come up with after probably about 3 months of messing around with loads of different designs. Also on the top of this main board, we've got the connections for the pogo pin flexible cable to come up to replaceable pogo pin port, which is USB 2 for the moment. I might look into doing a USB 3 version as an upgrade, but for the moment I'll probably stick with USB 2. And then on the other side, we've got the board-to-board connector for the NeoPixel and I2C, as well as the rocker. So that cable comes up to here, terminates, but then bridges up to this connection to send the NeoPixel and I2C lines up here. And then the rocker will be multifunction rocker. So there's a pop-up shortcut menu built into the Alternix and Wasp OS user interfaces, which gives shortcuts for mouse scroll, volume, and a few other options such as screenshot, the power menu. And then coming back down to the bottom board here, so you've obviously got the main compute module, which can be the Raspberry Pi CM4, the CM5, the Orange Pi, Radza, so many different boards capable. The 200 pin, not 100 pin each, but 200 pin high-rose connectors, And the board is placed upside down because the HDMI ports for the Raspberry Pi Compute Module 4 and 5 and the other boards are on the bottom connector. So we had to invert this whole compute module just to have a shorter run for the HDMI port, sorry. So also on the side here, we've got a modular system SD card slot, which again is on a board-to-board connector. And the 3D model is not the best, but yeah, you can get a rough idea. That's also replaceable. That is actually on the... So this is actually on the SPI bus. So in theory, we could have any other SPI devices in this connector as well, because a lot of these boards have built-in eMMC, so they have onboard storage. That's an option for the consumer to decide. Also down here, we've got the the most fun thing. This is the headphone jack. So the audio will route from the compute module high rows pins into this board-to-board connector, go into the back side of the headphone jack board, access to the headphone jack, but then also route up to another board-to-board connector, which with another flexible cable routes up to here. And that allows us to use the radio module as calling features, using the same speakers and microphone that is just down here on the front within the compute module system, as well as for calling. So that's pretty much where I'm at. I'm still routing out the bottom board at the moment. This is the first one I'm going to be doing, just this one. And then we can have the compute module or any of the other boards. I can then start customizing stuff for those specifically. And then I'll make them modular pieces. And eventually move on to the top piece. But yeah, so that's it in a nutshell. Thank you so much for watching. If you wish to support development of this, you can visit my Patreon, or I've set up a donation feed on my website. Here's the links also below in the description. I'll see you in the next one. Take care.